So we now want to investigate properties of events called independent and mutually exclusive. So in the last example, we saw that sometimes a given probability will change the probability of another event. That was conditional probabilities. Well, independent events A and B are where the probability of the first event A is not affected by the occurrence of B and vice versa. So there's three equivalent conditions that we can use to check if two events A and B are independent. And they are if the probability of A given B is the probability of A, so it doesn't matter that B is given, doesn't change the probability of A, or probability of B given A is the same as the probability of B. Again, it doesn't matter that A is given, they're independent, they have no effect on each other. Or the probability of A and B has to equal the probability of A times the probability of B. So this condition only happens for independent events. And these two are really the definition of independence. So let's see how this works with an example. Which of the following are going to be independent? Having heart disease and having blue eyes. Well, the color of your eyes should have no effect on whether or not you have heart disease. So we should say that these are independent. No effect on each other. And that's not a mathematical example, that's more of a daily life example. Having heart disease and being over 70? Yeah, those would have an effect on each other. The older you are, the more likely you are to have heart disease. So these are not independent, these are dependent. So when they're not independent, we call them dependent. So the probability of one event depends on the others. So there is an effect. Having a boy as the first child, having a boy as the second child. Well, it doesn't matter how many boys you have in a row, the chances of having a boy for the next child are always going to be approximately 50 out of 50. So these two events should be independent. Drawing a blue marble from 3 blue and 4 red marbles, replacing it, and drawing another blue marble. So while the probability of drawing a blue marble first is going to be 3 blue out of 3 plus 4, 7 total. But if you draw that blue marble and you put it back in, you're still going to have 3 blue and 4 red. So probability of drawing another blue marble will still be 3 out of 7. So these are going to be independent. Probability does not change. There's no effect. So that's more of a numerical example. Draw a blue marble from 3 blue, 4 red. Do not replace it. Draw another blue marble. So probability of drawing the blue marble first is 3 out of 7, like we mentioned. So probability of blue on the first draw is going to be 3 blue marbles out of 3 plus 4, 7 total. But then probability of blue on the second draw, well, you do not replace it. So you've taken 1 marble away and it's one of those blue marbles. So now it's down to 2 blue and 4 red. So this will be 2 blue marbles out of 2 plus 4, 6 total marbles. And notice that these probabilities change. They're not equal. So blue on the first draw, blue on the second draw, those are going to be dependent. So in part D, we had with replacement, drawing with replacement, that yields independent events, but drawing without replacement yielded dependent events. And that will almost always be the case.